Whether some more will join or should we start?
I think so. We can start. So
Okay. So yesterday we had started the welding, that is the joining process, and we mentioned there are several types of welding procedures. So to start with, quickly we shall observe what are the different procedures today. Then we shall discuss arc welding, because yesterday we ended up with gas welding, and resistance weld, electric resistance welding was also discussed. But after some time, again, we shall discuss about gas welding, because only just to brush up our memory. But after some time, not right now. Yesterday we had discussed gas welding, but again we shall just go through the superficially the gas welding procedures. But before, we shall start with arc welding. So I think it is okay.
Yes, sir.
Acha, before discussing, just I would like to mention the in chat box I am writing the names of books, or the all the books of manufacturing processes. As I had mentioned earlier, all the books contain this welding, but only for welding. There are some good books only for welding, right? And
okay, so
H.J. Little is one of the good books. Then again, Welding Technology by J. Davis. Okay. And another good book, Welding Technology by Parmar. So there are three good books on welding, along with so many other. But Parmar, for the time being, you may not go through Parmar, because Parmar basically is a mathematical, right? So there are various welding mathematics related with welding current requirement, so and so forth. So Parmar we shall not discuss in detail, because that is beyond our scope at the present moment. But you should know, because if in future, if you undertake some project in third year or in final year, uh, projects are there, major project and minor projects. So in those cases, these books will be helpful. But for the time being, you should go through at least H.J. Little, the first one is very good book. So this is about books. Now we are again returning. So I think this slide is available. Are you getting?
yes, sir.
Okay. So we had mentioned not in a tabular form, but you just observe the arc welding. So previously we had discussed gas welding, number 2. So what are the different techniques? Oxyacetylene, oxyfuel, oxyfuel. So oxygen, acetylene is the fuel, oxygen, hydrogen is the fuel, okay? Or oxygen, that is a supporting gas, oxygen is support combustions. So if we don't have oxygen, air may also be used, but that is not a good quality. So this is the oxyfuel welding. Resistance, electric resistance welding. So we had discussed about spot welding, beam welding, spot, seam, projection, butt, percussions. Percussions means flash butt welding. This is what is known as this upset butt and flash butt. Acha. Now there are so many other and related process. Related process. This is not welding, but utilizes this oxy fuel flame. So what is that? Cutting. Related process mean instead of joining, that cutting is initiated, and basically for ferrous metal, what we had mentioned yesterday. So oxyacetylene cutting, or we may have also arc cutting, bridging soldering. So we shall not discuss this arc cutting or hard fishing for the time being. Bridging soldering, again this joining process. So that will again be discussed. Some newer techniques like electron beam welding, laser beam welding, then solid state, these are also newer, friction, ultrasonic, explosive bonding, diffusion bonding, all these are various advanced technologies. Then submerged arc welding, so those will be discussed. Thermit, so what we mentioned yesterday again, thermit is utilizes the chemical reaction as a heat source, and that may be either fusion or pressure. So these are various categorization, but not all. There are so many other things. Now for arc welding, perhaps at least you are familiar with this arc welding because during your laboratory in the most likely first year workshop, or when second year first semester, there was a workshop on welding.
Yes, sir.
Second year.
Yes, sir. Second year, first semester.
Second year.
First year first semester.
No,
Second
sir.
year.
Second year, first semester.
Okay. So the welding was discussed at least in theoretical mode.
In online mode, yes.
Huh?
In online mode.
Online, but I think arc welding was discussed.
Yes, yes, yes.
Now, in that case, arc welding. So again, as we had mentioned, heat source or heat is a basic minimum in case of welding, right? So in arc welding, how heat is generated? Again, as the name suggests, electric. This is arc. Obviously, will be obtained from electrical sparks, right?
Yes.
And in using electricity, we may have either electric resistance welding. So the concept is something different, where heat source is H equal to I square RT. But here, how heat will be generated, that we shall discuss. Again, as it is electrical source, so we may have either a DC set. What is DC? Direct current, right? And
Yes,
one is transformer, AC transformer, alternating current, where there is no fixed polarity. Alternatingly, plus minus, these polarities are changing, alternating. But in DC, direct current, there are two fixed terminals, positive and negative fixed terminals. They are not changing. Okay, so, and how heat will be generated, all these will be discussed. So we must have in arc welding, these are the requirements or equipments. A generator, DC generator or transformer, etc. That is the heat source. Either AC or DC heat source. Now, this cable means electrical conducting material. Two cable, wire, right? Two cables. Why two? One for the work material, or not materials, parent materials, work material, which will have to be joined, and one for electrode. Now here the concept of electrode is something different. not this positive terminal or negative terminal as the concept is utilized in electrical energy. But electrode in welding, in arc welding particularly, sometime in gas welding also some electrode rod is used. That is nothing but filler metal. So what we had mentioned yesterday, if we require some additional material to be deposited, depending on the gap in between the two pieces, which depends on the edge preparation. Again, edge preparation depends on the strength requirement or types of joints, depending on the geometrical shapes, sizes, all these. Okay. So here electrode is that extra filler material. So electrode. So here we require two cables. One is for electrode and another is for work materials. We must have electrode holder because job will be held in a work table. Jobs will be clamped. You need not hold the job utilizing any tongue or something, but electrode should be held manually. If it is robotic welding, obviously robot welders are there, robotic arms are there, they will grip all these. So we must have electrode. So as we require electrode cable for electrode, so we must have electrode. These are also very important devices in case of welding. These two, protective shield and gloves. It means this protective shield is a blue glass through which you should observe the flame or the welding position, what is going on, because you should not look directly on the weld area, particularly arc weld area, through your naked eyes. Why? Because these rays which will be generated are very dangerous. That is, it contains ultraviolet rays, red rays, so that may contaminate your retina. Eye may be damaged. Okay, so that's why a protective shield is a shielding glass, also known as shielding glass, or a blue glass, a specially prepared glass. Not only the color is blue, but this is a specially designed, specially prepared glass through which ultraviolet rays, X-rays, UV rays, UV means ultraviolet, red rays, all these can't penetrate. And gloves are also used. Gloves, then other aprons, because gloves again, sometime you may feel some shock, electric shock, though there is a minimum chance. Why we shall again mention, but gloves should be used. And also there are various bars and corners, that is sharp edges of metal, pieces of metals, wares. So that's why a gloves is an essential minimum. And also in welding industries, fabrication industries, where workers, or particularly the welders, are operating continuously throughout the day, they must wear apron, gloves, all these. And if you visit in some industries or fabrication industries, you will observe, just like today's in COVID scenario, what we had observed, the doctors, they are all the time, they are wearing these PPEs, personal protective equipment. That is, all the body parts are completely covered. Similarly, in welding industries, in a fabrication industry, all the body parts of the workers are completely covered. Why? Because this, due to this arc welding or any other welding, various fumes or gases are evolved. Fumes and gases. Not only the rays, the red ray, X-ray, UV ray, but also uh, obnoxious gases are also formed. And that is also very, very harmful for not only for lung, but also for skins. Prolonged exposure with those obnoxious gases with your body parts may harm your body, that is even skin cancer. It may lead to some various allergic conditions or other things, irritations, and even cancers. So that's why this protection in welding industry is very, very important. And wear brass to, after say initial wearing, welding, you should break the weld portion by a chipping hammer. So I don't know whether things had been demonstrated during your online classes, some videos or something. But if you go through some videos, there are various good videos in internet. So you shall observe that after say one deposition of say one layer of metal, say I just am trying to say this is piece and this is say another, they are to be joined here. So first a drop of metal or a oiled bead is deposited. So one drop of metal, that is oiled bead. Similarly, a second bead and third bead, it will be continued, okay? So a solid joint will be prepared. But as soon as the first bead is deposited here, okay, immediately after that, or say you deposit, you continue, you fill the total gap here, first beading, whatever, just deposit a first line, and after that, you should use a chipping hammer. It is nothing but a just a striking edge. Here there is a striking edge made of iron. Okay, strike this portion, and as soon as it will be, the hammer will be used, uh, some layers will be separated. That layers are nothing but the oxide scales, oxide layers, because the welding is continued under atmospheric pressure or atmosphere. In room, inside the room, the atmosphere is there, atmospheric here. And this weld bead will be oxidized, oxide scales will be formed. So immediately after one pass, using a chip breaker or chipping hammer, chip breaker or chipping hammer, remove the oxide scales and then clean this area just by using a wire brush. Wire brush is also used to clean the area, that is to remove any sort of dirt, dust, grease, etc. from this weld area. Otherwise, good quality weld will not be achieved. So after cleaning, chipping and removing these fragments, then go for second pass. Again, break the chips. Again, go for third pass. In this way, depending on the thickness, section thickness, or strength requirement, number of passes may have to be given. And all the time, as soon as one single pass is followed, immediately it should be followed by chipping. Why? To prevent or to remove the oxide scales. That's why chipping hammer, goggles, as I have mentioned, protective shield, goggles, all these are just for protection. So these are the requirements. And here, how the arc welding is conducted. This is a gross figure where this is the welding machine, that is either welding machine, either one AC or DC source, okay, along with control, etc. So this is the machine. And there are, say, as we had mentioned, whether it is DC or whether it is AC, we must have two terminals, positive and negative. In the DC, the terminals are fixed, that is the polarities are fixed. But in AC, alternating, because AC, what is the sine curve? Okay. So
Yes, sir.
alternatingly, sometime plus, sometime minus. So all the terminals are changing their polarities. But only two such poles are there, electrodes. That's why there are two cables. So one electrode cable, say this is this cable, this is a cable, say this is connected with the electrode. This is the electrode holder, and on the top there is a electrode here. Electrode means a rod. This may be either, say, this is a bare wire. Bare wire means without having any coating material. So that may be electrode, bare wire electrode. Or generally in electrode some coating material is used, flask coating. So again we shall discuss in detail. So some coating material or flask material is used, just like what is agarbati, dhoop, agarbati, you are familiar with. So bare wire is the wooden stick on which some coating material are deposited. So something like that. This is the electrode, and this is the other cable, that is this other cable is connected with the workpiece or work cable. This is the work. And when arcing is initiated, this is the arc established, and this temperature of this arc is so high, the metal here will be melted, okay, and also the electrode material will also be melted and will be deposited over here. So after the completion, one bead will be formed like this. So this is all about. But there are so many things. So this is the arrangement. Like in gas welding, we have two cylinders. One is oxygen cylinder, another is acetylene cylinder or other fuel cylinder. There are two cables and one chamber, mixing chamber, and either a cutting torch or welding torch. And this is ignited here, then heat is generated. But here, this is the scheme. Now, question is how, as in the previous slide, we are observing some arc. So as soon as these two cables or say work and the electrode are struck and immediately separated by a small distance, air gap. Are you getting what I would like to say? Say this is the workpiece and this is the electrode. So they are just struck, touch kora holo. Okay, struck.
Yes, sir.
And immediately make a gap, air gap. So through this air gap, arcing will be established, arcing will be continued, arc will be established. right?
Yes,
But
sir.
question is how this arc, how this arc is established. You are striking the two electrodes and immediately separating the electrode, maintaining a very small air gap through which arc is established. Now, there are various theories behind this. One theory is electrical theory, which is not shown here, but say one is, this is second theory. First theory is electrical theory, not electron, electrical theory. Okay, electrical theory. And another is electron theory. Now, in electrical theory, first one, though it is not mentioned here, but you go through books, any books, uh, you will understand. Now, in electrical theory, what is happening? What is that theory? Electrical theory states that arc column is established when the two electrodes are struck and is separated by a small gap. Then how the arc is established as per electrical theory, right? So we have two terminals. One is anode, that is positively charged terminal, whatever, either work or electrode. Forget about that first. Either work may be connected with positive or work may be connected with negative terminal or cathode or vice versa. I don't know. For the time being, you forget. But we have work, that is job, and we have electrodes. So two terminals. So either of them will be connected with positive or negative. And we have a, say, DC current source. Because why DC? Why DC? Can you say why DC? Because AC, I can't say this is a fixed positive terminal, this is a fixed negative terminal. All the time they are changing.
Yes, sir.
That's
Yes,
why,
sir.
yeah, that's why when this column theory or arc column theory is discussed, it is discussed on the basis of DC. Say I have a DC power source, DCPS, DC power source. It is written in books like this. DC power source, and this is the, I mean, the symbol that is used for power source. And this is one cable which is connected with positive terminal, another cable connected with negative or cathode. Now in electron theory, listen carefully. Electron theory tells that as soon as the two terminals are connected and being separated by a small distance, ions, what is ion? Positively charged particles. Ions will be liberated at the anode terminal. Okay, number of positively charged particles will be liberated, and as they are positively charged, they will be attracted towards the opposite terminal, that is cathode. So this is the path, and they will be attracted towards cathode, and they will move from anode to cathode. And during such movement, so this is the ion flow. This is the ion flow in case of electrical theory. This is the ion okay, and when these ions are flowing, they will collide with the air gap. It is a small air gap, but air is there, so they will collide. And due to such collision, heat will be generated. Heat will be generated. But this discussion or this theory is not very strong theory, because a tremendous amount of heat is required to melt the workpiece. But how flow of ion can lead to the development of such tremendous amount of heat? That is not clearly understood by this electrical theory. So next development was the second concept, that is the electron theory. Electron theory. Now we know, we are not discussing, but if you again go through some books like say J. Little or any book, this is not needed, but for your understanding, you may go through any book, that is the electronic structure. What is the structure of an electron? You know, for any electron, in the center, there is a nucleus. There is a nucleus where there are proton and neutron in the nucleus center. And protons are positively charged particles, and neutron, they are neutral. And as this is positive, so it must have to be balanced. So in the outer shell, that is the orbital path, there are some particles moving. Those particles are electrons with negative charge. So this is the shell or orbital path. Okay. So this is a nucleus. Outside periphery, there are orbital path or shells. Number of shells may be there, K shell, M shell, N shell. So there are your, what is that? This in chemistry, that is key table, periodic table. So periodic table. So accordingly, there are so many elements. So number of proton, electron, etc. So that is other discussion. But this is the basis of this electronic structure. Now here, in electron theory, it is stated. Okay, let me just clean this. Okay. Now in electron theory, which is more strong, electron theory states that if the anode and cathode, that is the two terminals, are connected utilizing a DC power source, and as soon as they are struck and a small air gap is maintained, then not the ions are liberated, but electrons are liberated at the cathode surface. Just opposite, just think.
Yes,
Electrical
sir.
theory states that ions will be liberated, but here electron theory states that electrons will be liberated at the metallic surface or cathode surface, because electrons are easily liberated from the metallic surfaces compared to the ions. It is the phenomenon of any metal. Electrons can easily be liberated at the metallic surface. So when electrons are liberated, number of electrons, because thousands of electrons will be liberated, and they will be attracted towards the anode surface, that is positively charged terminal, with a tremendous high velocity. So they will be attracted. So this path, this arrow, and this is the middle or column of the path. Electrons are migrating or attracted towards anode. And all the electrons, say a single electron, have a small mass, very small. What is that? 9.1, 10 to the power minus 28. Minus 28, so very small. But when not a single electron, thousands of electrons are liberated, and they are moving, rushing towards the anode, right? And when electrons are colliding with the anode surface, they are attracted towards the anode and ultimately collided with the fouling, dhakka macche giye. So this collision, this is a collision, is known as, this term is important, electron impingement. This calling impingement. Impingement. Similarly, some ions will also be liberated. When they're comparatively lesser in number, ions will also be liberated at the anode surface, and being positively charged particles, they will be attracted towards this cathode surface, and that will create the outer envelope, outer path. This is the inner column, electron column, and this is the outer envelope. They will also collide. They are also traveling, they are also attracted, they are also colliding the cathode surface. And this collision, ionic collision, is named as ionic bombardment. So you should remember, though both are collision, দুটো গিয়েই ধাক্কা খাচ্ছে, দেওয়ালে ধাক্কা খাচ্ছে, কিন্তু ইলেকট্রনেরটার নাম হচ্ছে ইলেকট্রন ইম্পিঞ্জমেন্ট, আয়নিক কলিশনের নাম হচ্ছে আয়নিক bombardment. Now, so this is the science. Now, how heat is generated due to this? So, discussion is electrons have a very small mass, 9.1 into 10 to the power minus 28. When they are attracted or they are traveling with very high velocity, and are fouling, colliding, then this kinetic energy is given by, of a single electron, half mv square. You know, this kinetic energy is given by half mv square for a single electron. So thousands of electrons are joining, and mass times velocity to the power 2, half of that. So that is kinetic energy of a single electron. So thousands of electrons. Now, when the electrons are moving with this kinetic energy and finally it is colliding, this kinetic energy will be converted into a heat energy. Are you getting the point? Due to collision or electron impingement. Another
Yes.
part of heat will come from this concept, that is, all the electrons not only have a small mass but also have a very small electrostatic charge, 4.8 into 10 to the power minus 10 coulomb per electron. So thousands of electrons will contribute to some electrostatic charge also. So in this way, there are two portions of heat generation. One is due to kinetic energy, and one is due to electrostatic charge. Here also, anode will liberate some ions. They are also rushing with much less velocity compared to electron, and they will also collide. That is, kinetic energy will be converted into heat energy due to ionic bombardment, but they don't carry any electrostatic charge. So ultimately, major heat will be generated here on the cathode surface. Two-thirds of the heat, two-thirds of the total heat will be generated at cathode surface, and rest portion, that is one-third of the heat, will be generated in the anode surface. And due to the atomic collision in between, that is in the air gap in between, this is a medium heat zone, plasma area. Okay, medium heat. So this cathode area is high heat zone, anode area is low heat zone, this is a medium heat zone due to plasma or fouling with the atmospheric air. So this is the scheme: anode high heat, medium heat is cathode, is low heat, sorry, low heat. This plasma area is low heat. এটা বোধহয় উল্টো হয়ে গেছে। ক্যাথোডে টু-থার্ড, ইয়া, এটা ভুল হয়েছে, বুঝলে, এটা রং। this is high heat. Okay, high. This is medium and this is low plasma area. Is it clear up to this, or any question on this? Huh?
Yes, it is clear.
Clear to?
Yes,
So
sir.
now if this work, আচ্ছা আগেরটা, এক মিনিট, আমি একটু ভুল বললাম এখানটা লেখাটা, সরি, নোট খেয়াল করবি। So just sorry, this is this anode, right? So when electrons are liberated, they are striking here, and also as electron carries some electrostatic charge, so two-thirds heat will be generated here, not in the cathode. So this will be a high heat area. Two-thirds will be generated here, and as only ions are colliding, ionic bombardment, only one-third will be generated here. Just reverse, sorry for. Okay, so this is the picture. This is the high heat, this is medium, this is low heat. So in the this is I mean, this is also wrong, but now just check this. Are you getting this thing?
Yes, yes.
Yes.
Previously, I just due to misinterpretation, because electrons are rushing here, so maximum, so the terminal, positive terminal will have maximum heat, negative terminal will have less heat. Based on this, say if now say this is the work, a job, and job is connected with positive terminal, positive pole. Say this is positive terminal of the DC and this is negative terminal of the DC, and electrode is connected with negative polarity, negative pole. Okay, this is the job or work, and this is the electrode. Now if these are the terminals or polarity, job is connected with positive pole, that is anode. Electrode is connected with cathode terminal. So where the maximum heat will be generated? On the work surface. If maximum heat is generated on the work surface, what will happen? Metal will be melted at a rapid rate, right? And as soon as metal will be melted, electrode will also be melted, getting the heat, and the droplets will be deposited here. So when this work is connected with positive polarity pole, electrode is connected with negative pole, this is known as direct current straight polarity, DCSP. Note it, D stands for direct current straight polarity, DCSP. DCSP means when job or work is connected with cathode terminal, anode terminal or positive polarity, and electrode is connected with cathode or negative polarity. So maximum heat will be generated on work. When it is needed? When thickness of the job is very high. Say if I take a very thick job, so lot of heat will be required to melt the piece. So if thickness of the job is very high, that is the geometric relation. And also for metals which have very high melting point, like ferrous metal. But what will happen, say if I take a aluminium foil, imagine a foil, thin, very thin. And that aluminium foil is connected with positive polarity. So what will happen? Maximum heat will be generated. Immediately, the foil will be melted or burnt. That is, instead of joining, burning will take place. So in that case, DCSP will not be helpful. So what to do in that case? In that case, the work should be connected with negative polarity, and the work electrode is connected with the positive terminal. So maximum heat will be generated here. This will be melted at a very high rate. No harm. Droplets will be deposited, but less heat will be generated here. So this will not be melted rapidly. This concept is known as direct current reverse polarity, DCRP. So when it is needed, when the thickness are very less, like foil, or when the melting point of the metal is very low. So DCRP and DCSP, these are two very important considerations. Okay? And this is only possible, mind that, if you use a DC power source, because if it is a DC power source, this terminal is negative and this terminal is positive. So I can quickly change. If say work is to be connected with positive, just disconnect this terminal, connect with work, and disconnect this electrode terminal, connect with this negative. But in AC, you can't do that, because in AC, alternatingly, this will positive, this will negative, this will positive, this will negative, and so on. So in that case, 50-50 heat will be generated. So I have mentioned polarity, this is a polarity concept. DC, direct current straight polarity, direct current reverse polarity are important when the geometrical shape of the job, that is thickness, is concerned, when the metal melting point of the metal, that is the material characteristics, when melting point is a concern. There is another concern. There is another concern, that is weld position. Weld position. So what is weld position? So there are various weld positions, like vertical, horizontal, floor, floor, also called flat, roof welding. And this vertical, say this is a surface. Say this is a surface, wall. So I am welding. So this is the floor, say three-dimensional view. This is the room. Say this is the room. Okay. So I am welding on the wall vertically. So that is a vertical welding. Again, depending on where from I am starting, this is tops. I am starting here and coming down gradually. So this is known as downhill, downhill, downhill. Or if I start from this point and gradually move to upward direction, that is uphill. So downhill and uphill. This is the floor of my room. This is the floor of my room. And a crack has been initiated here. So to weld here, this is the floor welding or flat welding. What is horizontal welding? Say this is the wall. This is the wall. If I weld like this is vertical. Horizontal means parallel to the floor. So this is horizontal. Sometimes angular is also considered. Angular means some at an angle. Again, uphill, downhill. But roof, what is the roof? This is the roof. You just imagine, you just observe your roof where you are sitting right now. You look in upward direction, your roof is there. And a crack has been initiated at the inside roof area. So how to weld here? How to weld here? If you connect your roof with positive terminal, right? What will happen? Say metallic room. The roof is connected with positive polarity terminal. So maximum heat will be generated on that surface. And massive melting will take place and the total metal will immediately come down due to gravitational pull of action, force of action. And nothing will be deposited very slowly. Metal will be deposited very slowly, very difficult. Right? So what is the suggestion? It is suggested if sometime roof welding is to be done, then tilt the object in upside down manner. Are you getting the point? Tilt the object in upside down manner. Ulte dite hobe. So now it is like a horizontal or flat. So things will be deposited very nicely. But is it feasible or rather possible to tilt a room in upside down manner? Is not possible. So why I am telling, in engineering application, like say when if you visit some fabricating shop or rail wagon manufacturing shop, you will find when railway wagons severe welding action is taking place. So when roof welding is particularly conducted, they are following this procedure, tilting upside down manner to have a solid weld, sound weld. But say, for example, very large pressure vessel, very large your ship, very large ship, where tilting in upside down fashion is practically not possible. So you must go for roof welding. And you know, if the metal is connected with positive terminal, massive melting will take place. Deposition of metal will be very, very slow. So remedy is to utilize the concept of polarity. In that case, roof is connected with negative terminal. Whatever may be the material, whatever may be the thickness, irrespective of that. So third point, when the polarity is important, that is the position, welding position. So there are three important factors to be considered to choose a or to select a polarity. What are those? Material property, geometry, that is thickness, and welding position. Is it clear? So these are something about polarity. And now AC power source, if you use AC power source, uh, alternating current power source, we are tapping power from the bus line, from the main cable. So where the voltage is very, very high, that voltage can't be utilized. So I must take the advantage of transformer, step down transformer. Okay, so that will reduce the voltage, line voltage, to the usable voltage, usable limit. And when these transformers are used, that is quite in operation, noise is less, there is no noise, quite in operation, that is, and heat dissipation is also nil. So there is only small box. Small, I don't know whether you are familiar with AC transformer. Have you visited the laboratory after opening welding lab? No. So AC transformer, that is a trolley type. Some wheels are also there, balls. So you can easily transport from one place to other place. So that is transportable, easily transportable. Noise is very less. That is quite in operation. No smoke or fume generation. So atmosphere will absolutely clean. No heat dissipation. So all these are advantageous point. But the only disadvantage is, if you work, sorry, in a project work quite frequently, say railway, laying the rail tracks, or in a say remote area, some new construction is going on, where no power source is there. Now how to utilize this AC transformer? There is no power source. So you can't use AC in that case, in remote areas. So you must use another source, that is DC motor generator set, where no electricity is needed. But what is needed? Some fuel, oil based. As fuel is used, so smoke pollution, smoke generation will be associated. Sound is also very high for DC motor generator set. জেনারেটর চলে, দেখেছো তো অনেক সময় জেনারেটর চালানো হয়, it is associated with very sound noise. যখন লোডশেডিং হয়ে যায়, আগের দিনে ছিল বা অনেক সময় হয়. So noise, not only noise, as some some oils is used, diesel or kerosene. So some smoke generation, fume generation, and also the surrounding atmosphere will be heated. Heat radiation is also likely. And not only that, the generator set is very heavy in nature. So to carry, transport from one place to another is very, very difficult. But only advantage is that in a very sophisticated factory, you may have all sort of facilities, power source, all these. Still, you may have to use motor generator set when the concept of or question of polarity is concerned. That is the only technical advantage or importance of using motor generator set. If it is particularly connected with roof welding, you can't help. You must go for DC motor generator set. Or for thin foil, large thickness of job, high melting point. So you can't avoid. So these are the advantages as well as limitations. Only 1 minute, I just am. So these are the advantages and limitations of AC and DC motor generator set. Here, what are the advantage? DCSP, DCRP. So this is the major advantage or importance of using a DC set, along with so many others, all self-explanatory. So go through any book and find out the differences, distinguish between AC and DC welding or power sources. Now, how arc welding? So this is the scenario or arc welding mechanism. That is the electrode. So after some time we shall discuss about an electrode. So this is the electrode. Say this is the bare wire. This hatch portion is bare wire. Okay, and some coating is there, coating material, the coating. Okay, covering. Why it needed, all these will be discussed. Now, as soon as, so this is the job, this is the base metal or job, and this is connected with either positive or negative terminal or with AC transformer. Okay, this is also connected with either negative or positive or AC terminal, and they are being struck and separated immediately by a small air gap. So this is the air gap. So arcing is taking place here. This is the arc column, this arc stream. How arc is established? So we had discussed electron theory, electrical theory. And due to this arcing, tremendous amount of heat will be generated, and there a crater, a digging, by digging action, the metal will be melted and a crater will be created. Okay, and molten metal will be deposited. Molten, this bare wire, that is a metallic rod. So that will also be melted and that will be deposited in this pool, in this crater. So this is the molten metal deposition, right? Molten metal deposition. Gradually, this thickness will be enlarged, and this pool of molten metal or the crater is covered by what is known as this gaseous envelope or shield. Why this gas is developed or evolved? Due to the fusion or burning of this coating material. So gas will be developed or evolved, and it will create a shield or protection envelope. And due to this gas shield, it is also very important. As this is a shield, মানে একটা barrier তৈরি করেছে. So as this shield is created, heat will be dissipated from this crater or molten pool at a very slow rate, slow heat dissipation. Now you know, I think you have you have gone through the forging shop.
Yes.
So in this case, when the job is heated, sometime due to overheating, what you do? Immediately dip inside the water tank.
Yes, sir.
But what is the concept of this? From a very high temperature, dipping to a very low temperature suddenly is the concept of quenching, rapid cooling, quenching. Heat treatment, you know, heat treatment, you are familiar with this term,
Yes.
quenching. So, due to this quenching, particularly when the metal is enriched with carbon, martensite will be formed and immediately the metal will be cracked. Very brittle structure will be formed due to quenching, and immediately it will be cracked, crack formation. On the
Yes, sir.
contrary, so rapid cooling or rapid quenching is not desirable in various cases. On the contrary, slow cooling, that is normalizing. Just heat the job, place it below the normal atmosphere overnight or 2 days, 3 days, 4 days. Gradually, the heat will be dissipated. That will give very good mechanical property. So here, similarly, if the weld pool or weld metal get lot of time to be cooled, slow cooling, that is slow cooling, that will give sound property weld in the weld zone. So this gaseous envelope helps to reduce the heat dissipation of the weld metal. This is first point. Secondly, this coating material we shall mention, this is the bare wire, say made up of say copper or steel or the near material, base metal. What is the base metal? Say iron metal. So this is the iron rod. If it is copper element, copper metal, it will be prepared with copper. If it is aluminum alloy or aluminum, then this will be the aluminum, like similar metal. So when this is melted, and if this is covered with some coating material which is known as flask, some metals will also be melted. Coating materials contain various precious material like cadmium, vanadium, aluminum, nickel, chromium. Okay, so that will also be melted and will be infused with the molten metal. So as a result, this alloying effect will be accomplished. The base metal will get some costlier element like vanadium, cadmium, chromium, so which are there in the, so this is the second advantage. Some good quality alloying elements may also be infused with the molten metal. As a result, ultimately the weld quality will be enhanced. Thirdly, there is another advantage. That is, as this is covered with a gaseous shield or envelope, right? And here we have atmospheric air, atmosphere. And this is the weld metal or molten metal. So what we had mentioned earlier, immediately after depositing a bead, we must use a chip breaker or chipping hammer to remove the oxide scale. So if the molten metal is unprotected, then immediately oxide layers will be formed. Oxide layer means in atmospheric air, so many contaminants are there. Nitrogen, sulfur, oxygen is obviously there. So all the contaminants will make a scale or which is known as DOX, dross formation, dross, SOx, NOx, that is dross, oxide layers. So as this shield is or barrier is created, so atmospheric contamination will be reduced. So there are three tiers advantage of using one flask material. Okay. One minute. Here it is not written anyways. Okay, I am just writing the, this is electrode, right? This is bare wire, is coated with some coating material, is coating, these are the coating materials. So you just write, I am writing here in the chat box, what are the flask materials, just to, These are the FLUX, flux. Various materials may be used like ferromanganese, silica flour, asbestos, asbestos clay, so these are some flux materials that is used as a coating, and all these ingredients are bonded by sodium silicate liquid based binder. You know this thing. During our carbon dioxide welding, we had mentioned silica gel will be created, which acts like a cement-like substance. Is not it?
Yes,
Can you
sir.
remember?
Yes, sir.
So all these are ingredients are bonded by this. Now, electrode classification. There are several standards to classify, but we follow American Welding Society. These are very common. American Welding Society or American Society for Testing Material. You should know this abbreviation, that is AWS, American Welding Society, okay, or American Society for Testing Material, ASTM. What is ASTM? If somebody asks you, American Society for Testing Material, and they classify electrode like this: E followed by 4 digits, or E followed by 5 digits. E means electrode. E stands for electrode. And in a 4-digit system, the first 2 digits multiplied by 1000 refers that much of minimum ultimate tensile strength. One example, say if I write E7016, what is the meaning? This is a 4-digit representation. E stands for, this is an electrode, and first 2 digits 70 multiplied by 1000, that is 70,000, that much of psi, pound per square inch. What is that? Is the ultimate tensile strength that will be expected, that is expected when the joint is prepared with this electrode. This third digit in a 4-digit number, this is the third digit. Third digit stands for the weld position. What is weld position? We have mentioned flat, horizontal, vertical, roof, all these. So 1 indicates this electrode can be used in all positions. 7016, 1 means this particular electrode can be used for all positions. But if it is 2 means this electrode can only be used for flat and horizontal, not for vertical or roof. If it is 3, this is only applicable, or it can only be used for flat position. So obviously 1, which is 1, is more versatile. All this roof, etc., all this can be taken care of. So this is the nomenclature. Similarly, in 5 digits also, in 5 digit, the first 3 digit stands for the ultimate tensile strength. This fourth is position, and then the last digit here, the last digit, that is the fourth digit, or here the 5 digit, stands for the current source or power source. What type of power source, whether it is DC or whether it is AC. If it is DC, whether it is connected with positive terminal or negative terminal, or what else. So that is about the detail of power source. And in this regard, you must follow a table, that is power supply and characteristics. Now, if say power source, say, in our case, we have selected one example where 6 was the power source. So what is meant by 6? You come to this table, 6. 6 means power supply may be either AC or DC positive terminal. DC negative, AC or DC positive. And what is the arc action? That is the intense of heat. That is a medium heat. So medium. What type of flask? Low hydrogen flask. Low hydrogen flask. What is the nature of penetration? Medium penetration. Similarly, there are various up to 8 numbers. If it is 8, again AC or DC, here also AC or DC. So medium, low hydrogen, medium. So actually for AC, DC, these parameters are almost all same. But if it is AC or DC, say AC or DC, if it is 2, either AC or DC, no terminal positive or negative has been mentioned here. The digging arc action is medium. Type of flask, ductile material, ductile flask. Penetration is medium. Similarly, so many things, say if it is DC positive terminal, digging action, digging means more melting of the crater, flask, organic flask or mineral flask, penetration, deep penetration or medium penetration, etc., etc. So this is a table of power supply, regarding power supply. So at least you should remember at least 1 or 2, if say in question a short note is to be written or some part is coming, then you should at least give some example where you should mention this. So you should remember at least 1 or 2 figures. Another electrode, that is a corrosion resistant electrode. Corrosion is the unwanted wear of material when particularly due to chemical reaction. Not only chemical, there are 8 forms of corrosion. Unwanted wear. So to protect from corrosion, again, some electrodes are specified as per American Welding Society or American Society for Testing Material. So that is specified in this fashion: E 3 digits hyphen 2 digits. It means, say this is example E308 hyphen 16. The first 3 digit here indicates the type of steel. Type of steel means in steel handbooks there are so many type of steels, which is nothing but the chemical compositions. 308 is a very common. 308 means 18% chromium, 8% nickel steel. Chromium nickel steel. 18 chromium, 8 nickel. 18% chromium, 8% nickel steel. Chromium is corrosion resistant. Turbine blades are also enriched in chromium. And 1 stands for position, this 4th digit. Again, is the position. We have mentioned is 1 means all position. So here also position, all position. And 6 is the again power supply, AC or DC power plus. So in this way, these are the electrode specification. And another important concept is there in connection with welding on the say nameplate oil of the welding machine, AC transformer or DC motor generator set, there is a plate which indicates the name of the factory, name of something, date, etc., number, all these. Along with, there are 3 parameters that is mentioned. Those are mentioned. That is amperage, voltage, and duty cycle. This duty cycle is very, very important in welding because it is not possible to weld at a stretch for even 10 minutes. You may say, if you have a computer, or as we are doing right now, we are continuing for 1.5 hours. Another an hour will be continued with not that much of fatigue. But a welder can't weld continually for 2 hours, never.
Yes, sir.
Right? His eye will be fatigued, his hands will be fatigued, all these. So here a concept of duty cycle has been introduced. What is that concept? This is a 10 minutes period. Duty cycle, it is a standard. It is a 10 minutes period. So when a welder welds for continually for 10 minutes, then after that, his welded part will be observed and inspected. And say, if 60% is the duty cycle, it means when the operator operates for 6 minutes out of a 10-minute cycle, 60%, 6 minutes out of 10-minute cycle, with the rated output means the rating factors are written on the nameplate of that machine. Say 300 ampere, 40 volt is the rating cycle of that particular machine. So if the operator operates with those rating factors, that is 300 ampere at 40 volts at a stretch for 6 minutes out of 10-minute cycle, he can work for 7 minutes also, he can work for 8 minutes also, he can work for 10 minutes also, but without overheating or without making any damage. So that is the question. You may weld for continuously for 10 minutes, but your weld quality is very bad, so that will not be considered. If you can weld for 4 minutes, but that weld is a perfect weld without overheating, without damaging, without making any sort of problem. So that is considered as the duty cycle. Duty cycle may be 10% also, no problem. So that depends on the skill, ability of the welder. Okay, so this is the important consideration of duty cycle. Another factor is very important when the welding is arc welding is considered. 3 factors are very important: speed of the electrode travel, speed of travel of the electrode, ek number. Second is voltage, so speed of the travel of the electrode, then voltage. This is 14 approximately. (24 volt) for bare wire or lightly coated wire, lightly coated electrode. Bare wire, for bare wire or lightly coated, lightly covered electrode. But this is 20 to 40 volt for semi-coated and coated electrode. More voltage is required for coated electrode. And another parameter is amperage, that is current. Usually this is 500 ampere for manual operation. And this is why, because these maximum 40 volt are used and only 500 ampere is used, so we are not feeling any shock. Low volt operation.
Right, sir.
আচ্ছা, এখন কটা বাজে? Do you want to have some break or should we stop? What do you suggest? Hello?
হ্যাঁ স্যার একটু ব্রেক দিন স্যার।
ব্রেক করে আরেকটু এগোনো যায় নাকি?
ইয়েস স্যার।
তাহলে 5 minutes?
ওকে।
So right now this is 6:35. So we shall return at about 6:40. Is that okay?
ইয়েস স্যার।
Okay, sir.
Okay. Hello. Hello,
Yes,
can we
sir.
start?
Yes, sir. Yes, sir. Definitely.
Hello.
Yes, sir. Hello. We can start,
Okay.
sir.
Okay. Now, so as we had mentioned, so we had discussed about arc welding, heat source. What are the heat source in arc welding? Either AC or DC heat source, and the advantages and limitations of AC and DC sources, the polarity concept, DCPS, DC RP, DCSP, various welding positions, then the how arc is established in between electrodes, that is electron theory, arc column theory, electron and electrical theory. Electron theory is more powerful. Then we had mentioned about electrode classification as per American Welding Society or ASTM, classification of corrosion resistant electrode, the function of the coating material, three-tier function, three advantages. So these are something we had discussed in connection with arc welding. And as we had mentioned, there are various other welding techniques. So many techniques are there. Some of them are uh, older techniques, some of them are newer techniques, and so on. So carbon arc welding is one of them. This is not that new, but it is another technique. Arc welding, as the name suggests, this is also an arc welding, carbon arc, where nothing but you just observe the figure here. This is the weld metal or base metal. This is the molten pool, and here a carbon electrode electrode, as per now we had mentioned about electrode, either bare wire or coated electrode. So bare wire means basically the material, either aluminum or copper or ferrous metal, that bare metal. If it is if it is not coated with any coating material, so bare wire. But if no metal is used, but carbon rod is carbon rod, carbon electrode. So as carbon, obviously it is very conducting material. So it will be connected with one of the terminals, either positive or negative. Work will also be connected with either positive or negative. As soon as arcing will be started, this is the arc flame, and heat will be generated. Metal will be melted, and a molten pool of metal, gradually it will be solidified. But there is no gaseous envelope, mind that, as this is not coated with any coating material. And also, this carbon is not melting. Like in a electrode, there is a bare wire being covered with coating material. So bare wire, bare metal is melted. But here, no metal, that is carbon, is not melting. So that's why additional filler rod is used here. This is not connected with the terminal, but getting the heat from this arc, this filler rod will be melted. So metal will be deposited here. But here, the problem is some parameters are mentioned here. Later on, you may go through any book, or I may give you these slides for some guideline. So many books are there, you just go through, but just I am discussing the principle of this. But what is the problem? When carbon rod is used as an electrode, so carbon will be infused in this molten pool of metal. And as carbon is infused in this pool of metal, that is in the weld pool, this will become porous and brittle, right? So if carbon is infused here, the metal will become porous, that is weld pool will become porous, and it will be brittle also. But this is the technique, that is carbon arc welding. This is already mentioned, the differentiation. Now another two, these are also those, though this TIG MIG, you are also familiar with TIG MIG. TIG MIG, though these are also like carbon arc welding, these are also not that new, but still they are considered as advanced welding technologies. Advanced welding technologies. So what are the other advanced welding technologies like laser welding, atomic hydrogen welding, electron beam welding, friction star welding, right? Similarly, MIG and TIG welding. So what is TIG and MIG? First here, TIG, T-I-G, TIG, tungsten, this tungsten inert gas welding, T inert gas welding, TIG, also known as gas tungsten arc welding. This is another name, the same thing, gas tungsten arc welding, GTAW, TIG or GTAW, same. And here, this is the setup, this is the piece, and weld bead is deposited here. A job is connected with some terminal here, and this is the electrode. Now what is the electrode here? This is the tungsten electrode, where this tungsten electrode, you observe here. Tungsten electrode is non-consumable electrode. Now in carbon electrode here, it will be consumed, it will be infused, carbon will be infused gradually. So after some time, this will be used up. Similarly, electrode, when we are using electrode, rapidly the electrodes are consumed, consumable electrode, right? But tungsten, this will only help in arcing. It will not be consumed readily. But that doesn't mean, it is that concept is non-consumable electrode, but it doesn't mean never it will be consumed. Say if you use for 1 year, 2 year, after prolonged use, obviously the length will be reduced. But that is not the concept of consumption, right? So here a fixed tungsten is a costly element. So tungsten, and all these are mechanism, and these are the electrode holder altogether, that is inside. What is the name of this method? Tungsten inert gas. So there is a cable, say this is the cable, hollow pipe, through which shielding gas, inert gas, nitrogen or carbon dioxide or helium, argon, okay, no, that is inert gas, carbon dioxide, helium, nitrogen, argon, some gaseous envelope, gas is passed here in the work area. So gaseous envelope, inert gas shield is formed here. And if required, we may also utilize one filler material, filler rod. And here, shielding gas is entering here, it is covered. Sometimes it is also covered with some water jacket, because heat will be generated to dissipate the heat, to reduce the heat. Sometimes water recirculating water is provided. So here this is the tungsten electrode, which is covered in a gaseous envelope, and this is a inert gas, tungsten inert gas, or also known as gas tungsten arc welding. Inert gas is used, inert atmosphere. Aluminium industries, aviation industries, they utilize this TIG welding. Aluminium welding is in aluminium industries, the TIG welding is very prominent. So this is the description. Any book you will get this description, and this inert gas, shielding gas, like argon, inert, argon or helium or carbon dioxide. Okay. Both DC or AC can be used. So these are some technical points, pressure regulator, etc. So you just go through any book systematically, jot down some points, and also draw the figures, good figures. Try to practice good figures. And another TIG, tungsten inert gas. Another concept is MIG, metal inert gas, MIG. MIG, not TIG, MIG, metal inert gas, any metal other than tungsten. And here, this is a consumable metal, consumable. Now, what is the difference between an ordinary electrode? Here it is covered in, or it is working in gas shield envelope. So that's why inert gas, metal inert gas, but in ordinary electrode there is no inert gas. That is working under atmospheric air. And here it is also written as GMAW, just like say GTAW, gas tungsten arc welding. This is also known as gas metal arc welding, or MIG, same thing. And here a bare wire. So there is a reel feeder. In our welding workshop also we have a MIG setup. Now this is a reel, and through this reel, this is rotating. So there is a bare wire, bare rod. So two rollers are there. So there are two rollers. So if this roller say rotates in this direction, and this roller rotates in this direction, and the wire is passing through these two rolls, so what will happen? This will be advanced in this direction. So there is a reel or wire reel. So gradually this is consumed. Here this is the total setup, that is a gaseous envelope. So inert gas is fed here. So inert gas envelope, again helium, carbon dioxide, argon, those may be used. And we may also recirculating water to reduce the heat. Okay, so this will be covered. And in the workshop, if you observe this gas MIG, the spatters will come out. Yeah, sound will be there. You can also observe what is going on inside, because there is a clear gas shield, gaseous envelope. From this envelope, atmospheric contamination is prohibited, but you can observe what is happening inside. So this is a power source. And the electrode is a bare wire, bare or uncoated, and also consumable, not non-consumable tungsten. So here no filler metal is needed, because electrode itself acts as a filler metal. But in TIG, we supply one filler metal. So these are the some technical points. Okay, mixture of argon, carbon dioxide, or only argon, only carbon dioxide. All these are the research work. Mixture of 75, 25, 80, 20, which will give the good result. And you should know the electrode, what is used not only here, everywhere. The bare wire, that is the electrode, it should be such a material which is almost same or nearly the same. Same means chemical compositions are almost the same that of the base metal. Otherwise, mismatch will be there. Now, another interesting. We have mentioned about arc welding. Arc welding. We have also mentioned about metal inert gas welding, where inert gas envelope is created to protect the weld pool. But the spatters are coming, sound is coming, heat radiation may be there. So to protect all these and also to provide the envelope, shielding medium, another concept emerged that is known as submerged arc welding or SAW. Now, what is submerged? That is, this arc, this is say a base metal here, workpiece. And there is a wire reel, or that again a bare electrode, just like MIG. Just like MIG, a wire reel is there, a bare electrode, these are the rollers rotating. As these are rotating in this direction, so it will just pull the wire here. And this is also a consumable metal, right? And here we are not providing any gaseous envelope. On the contrary, here you just observe a flux tube, where from some flux material, a flux hopper is there, flux material. Now, what is flux that we shall discuss?